Hi, this is Dr. Eddie Morgan, ready to help you with your homework tonight. Tonight we're looking at the homework for Math 1, worksheet 8.1. Remember, every problem on the homework help mirrors a problem in your homework. So if you're having a problem with a particular problem, fast forward to that problem and we should be able to help you. So let's get started. The next four problems ask you to consider whether the transformation appears to be a rigid motion. Remember a couple things about rigid motion. First of all, they preserve, meaning they stay the same size, distance, that means one side when it changes will still be the same side, and angle measure. These two measures stay the same when you have rigid motion. Okay, that's the key. Try to remember that phrase because it shows up on the test several times to be able to say preserves distance and angle measures. Now you look at the first one and notice that the size changes. The pre-image is bigger than the smaller. So this one is no, it is not rigid motion because it does not preserve the size. The angles stay the same, but not the measures. And the second one, notice it's reflected, but essentially the angles and the size stays the same. So this, yes, this is a rigid motion because it preserves distance, the size, and angle measures. Number three, we have a situation very much like number one. Notice the pre-image is bigger than the image, so it's shrunk. So this is not rigid motion because the size changed. And finally, number four, even though it looks like it's rotated, the pre-image and the image are the same size, the angles are the same, so yes, this is a rigid motion. In the next two problems, they show us a solid diagram that's been transformed into a dashed diagram, and they want us to choose an angle or a point and from the pre-image, which is a solid, and name its image over in the dash, and then list all the pairs of corresponding sides. If you look at the first one, you'll notice that if you can't see it quite, this one's actually being rotated 90 degrees. Now, one way to see that is to note the first triangle is right triangle. The image, the right triangle, rotates that way. So we can see that A becomes A prime. So I notice that A becomes A prime, B rotates over to B prime, and C rotates into C prime. Now at this point, when we go to name sides, even though it's easy in this triangle, a little trick that'll help you is to use the angle names to identify the sides. And what I mean by that is, if you notice here, AB becomes A prime B prime. Likewise, BC becomes B prime C prime. And lastly, of course, CA starting here and going up becomes C prime A prime. Notice how I just switched the letters each time. Now for something like ABC and A prime, B prime, C prime, that's pretty easy. But when we get to number 6, it's not quite as easy. Notice in number 6, this thing actually rotates an entire 180 degrees. So the top W is now on the bottom L. So let's start putting these together here. For example, we see that U down here rotates up to the top and across J. V moves over to K. And as we saw, W goes down to L. X goes to M. And then finally, Y goes to N. Here's where our little trick helps a lot. If I want to know, for example, where does UV go? Well, UV goes to JK. And then we can go on down and say, okay, VW is going to go to KL. And WX is going to go to LM. XY is going to go to MN. And finally, YU is going to go to NJ. 7 and 8 ask us to graph each of the figure with a given translation. Notice up here that X plus 2 means that I'm going to go right 2 and I'm going to go Y down 2. So just pick a point here and I go right 2, down 2, there's my point. This Y with Y, right 2, down 2, there's my point. X, right 2, down 2, there's my point. And I can draw my new triangle. Now for 8, X plus 3 means once again I'm going right because that's positive 3. And here again, I'm going, this time it's plus 4, so I'm going up 4. So we pick a point here and start. D, I go right 3, up 4, and there's my point. Go back over here to A, right 4, up 3, there's my point. B, right 3, up 4. And C, right 3 and up 4. And then I draw my new parallelogram. In problems 9, 10, they're showing the dash figure, which is the translation of the solid figure, and wanting us to write the rule. So pick a point and look at the translation. For example, if I pick point A, notice it goes over 2, left 2, and down 5. So that means that's x minus 2 and y minus 5. So there's my translation, x minus 2, y minus 5. In number 10, notice the solid figures on the left. So I pick a point here like x. It goes over 4 and up 3. So that's right 4, up 3. So that's going to be x plus 4 and y plus 3. Problem 10 says to plot the image of AB, the line segment, after the given transformation. Notice again, x minus 2 means that this is going to go left because it's negative 2. Y plus 3 is going to go up 3. So I pick a point here. A, I'm going to go left 2, up 3. There's A prime. B, go left 2, up 3, and there's B prime. Connect it, and there's my line. 12, we're doing the same thing with AB. This time, x plus 5 means I'm going to go right 5, positive. Y minus 2 is negative, so I'm going down 2. So let's start here with A. We're going to go right 5 and down 2. And there's A prime. With B, we're going to go right 5 and down 2. There's B prime. Connect it. And there's our answer. 13, similar again. X plus 3 means positive. I'm going to go right 3. Y plus 2, positive. I'm going to go up 2. So let's start with A. Go right 3, up 2. There's our A prime. B, go right 3, up 2. And there's our B prime. Connect the lines, and there's our answer. Problem 14 asks us if the two parallelograms on the coordinate plane are congruent. If you look at them, they look like they're the same. And if we examine them, we recognize, yes, this is a translation. Notice it's simply, like if I look at point A, it just simply went over 2 and it went up 4. So that's a translation, and a translation is a rigid motion transformation, and it preserves distance and angles. So we know that these two quadrilaterals, these two parallelograms, are congruent. Our last three problems ask us to write the rule that describes the transformation. So let's just take a look here. 7 left means that I'm going to take x and I'm going to subtract 7. 3 up means that I'm going to take y and add 3 because it's positive. So my rule looks like this. xy goes to x minus 7, y plus 3. And number 16, 5 right means it's x plus 5. Right is positive, left is negative. 2 down means it's y minus 2. And so our resulting rule is going to be xy goes to x plus 5, y minus 2. And finally, 1 left is going to be x minus 1, negative. 4 down is going to be y down 4. So our answer there is x minus 1, y minus 4. Hope that helps you with your homework. Have a good evening.